Hi everyone, good morning. So let us continue from the last discussion. So when we had a quadratic equation in the form a times x squared plus b times x plus c equal to 0. Now when you are solving this quadratic equation, we can use so-called the quadratic formula. So we will expect to have two solutions. Let me write down as x1 and x2. So previously we already derived this formula, which is the solution x1 and x2 equal to minus b plus and minus square root b squared minus 4ac divided by 2a. So basically, this tells us if we have, for example, a quadratic equation. So let me give you an example here. X squared minus 3x plus 2 equal to 0. So now we are going to solve this one. In this case, you need to know these values of a, b, and then c. Yeah. So you see, a is just a value, or we call it coefficient, in front of the square term here, x squared. So it is 1, and then b, it is this value in front of the x. So in this case, it's minus 3, and then c is just a constant. So in this case, it's plus 2. So I will write here a equal to 1, and then b equal to minus 3, and then c equal to 2. And now if we want to solve this solution or the roots, so therefore using that formula again, we can get x1 or x2 equal to minus b, which is minus 3, plus or minus square root minus 3 squared, and then minus 4 times 1 times 2 divided by 2 times 1. So if we calculate the number, we get plus 3, and then plus or minus square root 9 minus 8 divided by 2. So in this case, we get 3 plus or minus. Now you can see here the value of square root 1 is just simply plus or minus 1. Therefore, if we consider with the positive number, so x1 or x2, so basically, let's get the first value first, x1, yeah? It will be 3 plus, so in this case, we use this symbol here, plus 1 divided by 2, and we got the first solution of that quadratic equation, yeah? X1 is equal to 2. Now, the second solution, x2, will be 3 minus. Now, you see we have also that minus, so we'll use the sign now here. And then 3 minus 1 divided by 2. And in this case, we got 1. So therefore, you see, we have two roots here, plus 2 and then plus 1. And the thing is like this. If you look at again, the quadratic equation that we have here, x squared minus 3x plus 2 equal to 0. Yeah. What happened is actually this originates from so-called the quadratic function fx. Fx equal to x squared minus 3x plus 2. Or I can also write down, remember that this fx is also y, so y equals to x squared minus 3x plus 2. So now when you are plotting this y equal x squared minus 3x plus 2, say we are using now a website. Yeah, so let's go to here, this one, Desmos. So basically, this is the plot of x squared minus 3x plus 2. And as you can see here, what we have here is a parabolic graph, parabolic curve, yeah? So you can see this is the typical parabolic graph, and we'll talk about this in detail further later. Now, if you look at the graph here, that you see, what you see here is this graph cuts the horizontal axis, the x-axis, at 2 points. Here, the first point there, it's where x equal to 1 there, and then the second point here, x equal to 2. So basically what happens is when you are solving the quadratic equation, actually we are equating this quadratic function y with the y value equal to 0. So that's how you got those 2 points. So if you look at these 2 points, the value of y at those 2 points is at y equal to 0. So when you equate that y equal to 0, here we go, we get the quadratic equation, right? And you see, actually when you have a quadratic equation like this, yeah, what happens is sometimes this quadratic equation can give us 2 solutions, like this case here, where the first x is equal to 1 and then the second one is equal to 2. But that's not always the case, because sometimes when you have a quadratic equation, what happens is sometimes that quadratic equation only has 1 root. Or sometimes in the other cases, the quadratic equation can also have no real solution or no real root. So this is actually something that you need to know now. When you have a quadratic equation, and then how can we tell if a quadratic equation will have 2 roots, like the one that we have here, or it will have only 1 root, or it doesn't have any real root. Now you must go back again with the original, the general form of quadratic equation. This is 0 equal to ax plus bx plus c. And you remember that when we are solving this quadratic equation, we use this quadratic formula, which is x1 or 2 minus b plus or minus square root b square minus 4ac divided by 2a. So what happened here is actually there is a value inside this square root. You see, this b square minus 4ac. So this value is called discriminant. Or sometimes some other people call it delta. So this is, again, this is called discriminant. And some other people call it delta. Now, again, this value delta is simply the value b squared minus 4ac. So what happens here is when you now calculate this discriminant, you will get a number. Now, this value of discriminant can be larger than 0, or equal exactly at 0, or smaller than 0. So that tells us different cases. Basically, when you have the value of the discriminant is larger than 0, therefore, you will get 2 roots. So this is like what we have here. Basically, when you are doing this quadratic equation, and then you remember that the value of a equal to 1, and then the value of b equal to minus 3, the value of c equal to 2, and then try to get the value of the discriminant, therefore we'll get, you know, b squared minus 4ac, and then you'll get minus 3 squared, and then minus 4 times 1 times 2, where we get this number 1, which is larger than 0. So if that's the case, of course, what you will see here is you will get 2 points, 2 roots. But sometimes the value of the discriminant is simply equal to 0. In that situation, when you are calculating the discriminant and you get 0, therefore, you will get 1 root. The example of this is actually simple. I can give you an example of this case, yeah. So if you look at again now the quadratic equation here, that I will have now, instead of plus 2 point, just plus 2, now I will add a bit 2.25. And you can see now this graph, the parabolic graph, it only touch the horizontal axis at one point here, 1.5, which shows us now you only have one solution or one root when you are solving now this quadratic equation. 0 equal to minus 0 equal to x squared and minus 3x plus 2.25. Why that happens? Because when you are now calculating the discriminant, this is what you will get. So minus 3 squared and then minus 4 times 1 times 2.25. Therefore, you will get 0. So this is what happens actually when you have the discriminant equal to 0. But then you see, if you have the value of the discriminant now, say it's smaller than 0, so let me make it bigger, this number. So for example, now instead of 2.25, you have plus 3. And you see what happens now, that parabolic is no longer touching the horizontal axis anymore. So it's like hanging above the horizontal axis. So in this case, we do not have real root. Yeah, we do not have real root. So that's what happened now. No real root. And this is because, when you are calculating the discriminant of the quadratic equation, x squared minus 3x plus 3 equal to 0, what you will see is the discriminant will be a value which is smaller than 0. So if you can calculate the number now, yeah, minus 3 squared, and then you subtract by minus 4, and then times 1 times 3, so which gives us minus 3, which is smaller than 0. So that's the third case where the discriminant is smaller than 0, or in this case we don't have real root. Of course, in the future discussion, we can work with this situation further when we learn something so-called the complex number. But at this point, at this moment, let's not worry about this final case where you have the no real root, or we call it imaginary root. So I guess this is what I'm going to talk with you today, yeah, about a quadratic equation, and how to get the roots, especially using the quadratic formula. And now you can tell also if your quadratic equation will have 2 roots or only 1 root, or even no real roots. Yeah. So that's for today, and I'll see you again next time. Thank you.